For centuries, Mars has been a puzzle. We see a frozen red desert, but everywhere we look, we find overwhelming evidence of a watery past. Our rovers have found dried-up lake beds, and orbiters have mapped out vast river valleys. There's even what looks like the ancient shoreline of a northern ocean. All the signs point to the same conclusion. Mars used to be warm, wet, and covered in water. So, where did it all go? For decades, scientists figured most of it was lost to space after the planet's atmosphere disappeared, with the rest frozen at the poles. But the math never quite worked. There was always a huge amount of missing water in the budget. Now, thanks to seismic data from deep beneath the Martian surface, we might finally have the answer. And while some are calling it a buried ocean, the truth is a lot more complex and, frankly, a lot more exciting. This story starts with NASA's InSight lander, a silent sentinel on the surface of Mars. Its main job wasn't to look for water, but to listen. From 2018 until its mission ended in 2022, its ultra-sensitive seismometer recorded the faint rumbles of the red planet, listening for marsquakes and meteorite impacts. In 2021 and 2022, InSight hit the jackpot. It detected several massive seismic events, including 2 big meteorite impacts in the largest marsquake ever recorded, an event called S1222A. These powerful events sent shock waves rippling right through the planet. By studying how those waves traveled, slowed down, and bounced, scientists could finally piece together a map of what's hiding in the crust. And what they found was startling. At a depth between about 5 and 8 kilometers, the seismic waves suddenly slowed down. In geophysics, that's a dead giveaway. The waves weren't just moving through solid rock anymore. The leading theory, published across multiple studies, is that InSight found a massive, water-saturated layer of porous rock. Don't think of it as an open sea, but more like a colossal, deep earth sponge, absolutely soaked with liquid water or heavy, salty brines. This discovery gives us our biggest clue yet in solving the mystery of Mars's missing water. The idea is that billions of years ago, as Mars started to freeze and lose its atmosphere, a huge amount of its surface water didn't escape to space. It just seeped deep underground. Protected from the harsh radiation and kept liquid by geothermal heat and immense pressure, it stayed trapped inside the rock. And the amount of water we could be talking about is staggering. Based on the seismic data, some models estimate that if this reservoir exists as predicted, there could be enough water to cover the entire planet in a global ocean between 500 and 800 meters deep. Some of the more optimistic estimates suggest Mars could be hiding enough water to form an ocean up to 1 or 2 kilometers deep. While this is all based on models, those numbers line up incredibly well with how much water scientists thought was missing from the planet's budget. This isn't definitive proof, of course. The evidence is still indirect, a clever interpretation of seismic echoes. But it is the strongest evidence we've ever had that Mars's ancient water isn't gone forever. It's just hidden. For the search for life, this changes everything. The surface of Mars is a brutal place, blasted by sterilizing radiation with wild temperature swings. But deep underground, it's a whole different world. This potential reservoir would be shielded from all those hazards, creating a stable, long-lived environment. And wherever we find liquid water, there's at least the potential for life as we know it. Here on Earth, we've found entire ecosystems of microbes thriving in deep earth aquifers and lakes buried under glaciers, completely cut off from the sun. Discovering a similar, ancient, water-rich zone on Mars dramatically expands the places we can look for biology. The hunt might shift from searching for tiny fossils on a dry surface to one day probing these deep, potentially habitable zones. What do you think? Does the idea of a hidden, watery world beneath the red dust change how you see Mars? Let us know what you think down in the comments. So does this mean future astronauts on Mars can just drill a well and hit a gusher? Unfortunately, not anytime soon. The depths we're talking about, between 5 and 20 kilometers in some models, are enormous. That's deeper than the deepest holes ever drilled on Earth. Getting to this water is far beyond what our robots or even humans can do right now. For now, this discovery isn't about finding a water source. It's about changing our fundamental understanding of the red planet. It suggests Mars isn't just a dead, frozen world, but one that might still have a hidden, active hydrosphere. Future missions will now be designed with this in mind, carrying instruments that can confirm and map these deep reservoirs. We haven't found an ocean we can swim in, but we may have found something far more valuable, a brand new roadmap in our search for life, and a clear sign that Mars still has profound secrets waiting to be discovered.